Okay, as I mentioned in the video last week and the Google form that we took as a pre-assessment that I was going to use to help guide instruction, this week we're going to focus on quadratics, and there's guaranteed to be a few questions on quadratics on the SAT. So just a quick review, because you do have access to a graphing calculator at times during the exam. So if we were given the equation 2x squared plus 5x minus 3 equals 0, we're asked to find the solution or the solution set to this problem. By graphing it, we can see that it crosses the x-axis in two places. So there's going to be two places, there's going to be two solutions. So I go to y equals, and I would plug this equation in. Then I would select graph, and then once it graphs, you want to hit calculate, and then you're going to move the cursor around, and you want to say left bound, right bound, and then it will guess. So you can move the cursor a little closer and hit enter, and then it will give you an answer. And when you would plug this in, it would say x equals -3. And then you could do the other side. If you would do that in a calculator, you would get x equals 0.5. So if you want to double check, just to refresh your memory on how to do that in a calculator, that could be helpful and save you some time. So go ahead and do that. On the no calculator section, it gets a little more hands-on, and we always want to have our quadratic formula ready to go. So if we're given an equation like 2x squared minus 4x minus 30, we want to quickly identify what the different variables are. So a would be 2, b would be -4, and c in this case is -30. So now we want to just plug into this formula, and we want to do some algebra and solve. Obviously the negative of -4 is 4, so plus or minus -4 squared. And we finish plugging in. Then what we want to do is simplify. -4 simplify. 4 squared, 16. 2 times 30, 60 times 4 is 240. And this is a negative, so negative times a negative makes this addition. And now when we add these together, we want to have, let me use a different color over here. We want to, memorize our perfect squares, because 240 plus 16 is 256, which when we take the square root of 256, we want to know this pretty quickly. Oops, don't need that. That's 16. So we get 4 plus or minus 16 over 4. When we add 16, divide by 4, we get 20 over 4. So we would get x equals 5. And then when we get 4 minus 16, we get -12 divided by 4, and we get x equals -3. So that would be our solution set to this problem. Okay, just some other general tips. Obviously, when we're talking about quadratics, we really want to be careful, because like I've been saying all year, you'll be able to solve the quadratic correctly, and then they're going to ask you, a different type answer, just slightly, vary the question in that way, like we've seen all semester. And also, just a little reminder, you may see the terms find the root, find the x-intercept, find the zeros when we're talking about quadratics. This is all the same thing. So here is the first example from the Google form last week, and did see a couple right answers, and these are fill-in questions, and the correct answer to this is -7. So kudos to you if you got that. I know I saw a few of those. And sometimes we have to work backwards and apply those strategies that we've learned all year. And the number one strategy is that plugging in numbers. So we're going to utilize that. We know that 4 and -1 are solutions to this problem. So let's plug in for x with 4 and -1. So on one side, we'll have 4 squared plus 4 times b plus c. That's equal to 0. And then on the other side, we'll do the same with -1. So we get -1 squared plus b times -1 plus c equals 0. Now we can clean it up a bit. Over here we get 16 plus 4b plus c equals 0. And then on this side we have 1 minus b, minus b plus c equals 0. Now both of these are equal to 0, so these are equivalent expressions. So we can set these equal to each other. So 16 plus 4b plus c is equal to 1 minus b plus c. Now, if you notice, we can get rid of one of these c's by subtracting it to the other side. So why don't we do that? So I'm going to do it all in one step because I'm running out of room. I'm going to move the 16 over to the other side. So 1 minus 16, I'm going to have negative 15 over here. I'm going to add the b. It's going to cancel here. Plus b. So on this side, I'm going to get 5b. And then, like I said, I'm going to subtract the c, which is going to cancel that on both sides. So I get 5b equals negative 15. So b is definitely equal to negative 3. But now we don't know what c is, so it doesn't really matter. We can use either equation. Let me use this one. Okay, so for b, we're at negative 3, so we get 16 plus 4 times negative 3 plus c equal to 0. Now we get 16 minus 12 plus c equals 0. Then we combine 16 negative 12, which is 4, move it to the other side. We get c equals negative 4. Now remember, this wants b plus c for the question. So if we have negative 3, we add it to negative 4, we get negative 7 as our answer. Actually, a repeat of a problem that we did early on in the semester. I think exponents was the third or fourth topic that we focused on. So I wanted to see who was paying attention and to see if it's worth showing again. And I think it is, because this is a tough question that, if we look at it, it's pretty intimidating. But remember, when we want to know, our rules. So we have 3x squared times 27x equals 3 to the negative second power. Now, the first thing we want to do is we want to change this base. So we get 3x squared, and we want to change 27 to 3. Remember, we can't just change a number. So 3 to the second power is 9. 3 to the third power is 27. So remember, when you have two exponents, you multiply those together. An exponent raised to a power, you multiply them. So we have 3x equals 3 to the negative 2. Now remember, when you have two numbers with the same base and we're multiplying those together, you can add those exponents. So essentially, if we just focus on the top, we're adding those since we're multiplying, equals negative 2. Now I'm going to move it over. X squared plus 3x plus 2 is equal to 0. Now this is a nice quadratic. We can solve. We can just factor this out. FOIL it, or the box method, as you say. So we want two numbers that multiply equal 2, and they add up to 3. So we're going to have a solution of x plus 1, x plus 2, and now the solutions would be x equals negative 1, x equals negative 2. And now this wants the product of all values, so that satisfies this equation. Our answers are negative 1 and negative 2. We multiply those together, and we get 2. The third example on the Google form, and I bet you were thinking, hey, Mr. Palermo, why are you assigning systems of equations when you said, we were going to focus on quadratics? And as you see, there is quite a bit of overlap on this in the SAT in general. So the first thing I want to do, okay, we know y equals 7, right? And if we graph that, that's going to be a line. This really doesn't make sense to me right now, so let's expand it and FOIL it. I like the term FOIL. I know a lot of you say the box method, but first, outer, inner, last, that always helps me. So when I FOIL this out, I'm going to get negative 2x squared, okay, 2 minus 3x plus 5, okay? Okay, so that's what I'm going to get. And we know that y equals this. So how many ordered pairs satisfy the systems of equations above? Now, if I have this, I'm praying that this is a calculator problem, because in my calculator, what I'm going to do is I'm going to throw both of these into the y equals section, and I'm going to get a graph. This is a negative parabola, so let me plug it in quick. I'm going to get something, this is not going to be perfect, that looks like that, and then when I graph y equals 7, I get a nice straight line somewhere along there. And since these do not intersect at all, there are going to be no solutions to this problem. Now, if this were a no calculator question, we would have to use the quadratic formula, which I'm not going to do right now because that would take me a little extra time, and the SAT were precious for time. But if we were to use the quadratic formula to solve, we would get imaginary numbers, and therefore that would show you that there are no solutions to this equation. Okay, here's the fourth example of the Google form that I want to go over, and in my opinion, this is the most difficult one and is very tricky. So the first thing that I would do is, this isn't really an equation we can plug in, so let's just rearrange it quickly. X squared plus 2tx plus 8 equal to 0. Okay. Now, if you can get one thing out of this, most of the time, if you ever see this term plus minus, where we have negative t plus or minus 3, wherever we see this plus minus, we should think use the quadratic formula. So that's exactly what I'm going to do. So negative b plus or minus b squared minus 4ac all over 2a. Okay. Now, sometimes it's helpful, but if we want to say a is equal to 1, b, it's not equal to 2, it's equal to 2 times t, which makes this equation a little tricky. So, and then c, obviously, is 8. So now let's start plugging in. X equals, so b is this 2t, so negative 2t plus or minus, use different color just so we're organized. So we're going to get 2t squared minus 4 times 8 all over 2. And 2 times 1, right? We want to plug in for everything. Now, here's where it gets a little tricky, but let's expand it a little bit. So x equals, we'll say, negative 2t over 2 plus or minus, so I made that too big, square root, so 2t squared, that's going to be 4t squared. 4 times 8, 32, all over 2. Okay. And then if I want, this can cancel out, right? Negative 2 divided by 2. So that's going to cancel. I'm just going to erase it because I don't have a lot of room. So we get negative t equals square root of 4t squared minus 32 all over 2. Now, according to this problem, t is greater than 0. So if we know that the solution, like x is equal to negative t plus or minus 3, but x is going to be equal to 3 if that's the case. So let's plug that in. So we're going to get negative t. Actually, I lied. We're not going to do that. Now we can see that over here we have negative t plus or minus, and then this whole thing. And the problem tells us negative t plus or minus 3. So this is going to be equal to minus 32 over 2. That's going to be equal to 3. So now I'm going to cross multiply each side by 2. So you get the square root of 4t squared minus 32 equals 6. Now what we want to do is we want to square both sides. Square. So 4t squared minus 32 equals 36. So we add 32. Okay, so then do it over here. 4t squared is equal to 68. Okay, divide both sides by 4. So we get t squared is equal to 17. Now we don't have to take the square root of t because this problem just wants t. Video got cut off, but like I was saying, this just wants t squared, and what we found was t squared, so our answer to this problem is just 17. So when we're going through these problems, just be very careful about what it's asking, and just trust yourself to stay focused and do that algebra.